Hello everyone, hello students. Today's video we are going to continue the mole concept and the stoichiometry, right. So, in the previous session we have done with the small what are the atom, atomic mass unit, what is the mole, how to calculate the number of grams, number of atoms, number of gram atoms, number of moles and number of molecules like. So, in today's video we are going to calculate mass percentage and how to calculate the empirical formula and molecular formula and some of the calculations of empirical formula and molecular formula, and then stoichiometry basics, means what is meant by stoichiometric equation, like that we are going to learn in today's video. So, just start our video, right. See, first one is mass percentage or percentage of mass. How to calculate this mass percentage first of all? See, suppose you take one molecule CH4 is there. CH4 is a methane molecule. In that molecule 1 carbon and 4 hydrogens are present, right. So, what is the percentage of carbon in methane? What is the percentage of hydrogen in methane? Because CH4 two molecules are there, right, means two atoms are there, one carbon atom and 4 hydrogens, right. What is the percentage of carbon and what is the percentage of hydrogen in the given CH4? That is nothing but the calculation of mass percentage, okay, or percentage of the mass. See here, this one is defined as the concentration of element in a compound or component in a mixture. How much amount of the compound is present in the given amount of the molecule, right. So, in CH4 what is the percentage of carbon? Calculation is nothing but the mass percentage. How to calculate that one? How to calculate that percentages? See here, we have a formula for that percentage of mass of an element, that is atomic weight of that element, means in which element you want to calculate the mass percentage, that element's atomic weight into how many number of atoms are present, means how many number of atoms are present in the given molecule, gives you number of atoms of that element in the given molecule by total molecular weight into 100, because we are calculating the mass percentage, right. So, into 100. This is the formula for the calculation of percentage of a mass of an element in the given molecule, right. So, let us see. Let us take one example and calculate the mass percentage. See here, I am taking here CH4 as one example, and I want to calculate even for 3 atoms, means 3 elements containing molecule. Suppose we can take CH3OH, because in this oxygen also involved, or else you can take NH2OH also, right. Let us calculate for this, not alcohol, because both are same. So, I want to calculate the individual mass percentages for this molecule and NH2OH molecule also, right. See here, come to the first one, CH4. I want to calculate the percentage of carbon. So, I will take here percentage of carbon equal to atomic weight of carbon. What is a carbon's atomic weight? 12 into how many number of carbon atoms are there in the given CH4 molecule? Only one carbon atom. So, I will write into 1 by what is the total molecular weight? See, for one carbon 12 plus for hydrogen is 1, like that we have a 4 hydrogen atoms. So, 4 into 1. So, total 12 plus 4 is gives you 16. 16 is the molecular weight for CH4. So, I will write that only here. So, 12 by 16. This is simply 4 3s are 12, 4 4s are 16. 3/4 part in 1 is nothing but 75%. 3 by 4 is nothing but 75%, right. In 100, if you take 3/4 part of carbon, overall CH4 compound you consider as 100, in that 3/4 part carbon only there, means 75% carbon is present. Calculate the hydrogen's percentage also. Percentage of hydrogen equal to, what is the atomic weight of hydrogen? 1.008, but I am taking here as 1 into how many number of hydrogen atoms are there in that molecule? 4 hydrogen atoms are there. So, I will write here 4 by what is the total molecular weight? 16 already we found, right? So it is called 4 by 16. 4 by 16 is nothing but 1/4. Total in 100, 1/4 part is nothing but 25%. So in CH4 molecule is considered, percentage of carbon is 75% and percentage of hydrogen is 25%. This is the mass percentage or percentage mass for the given molecule. You can calculate for any molecule. Suppose take here NH2OH, right? For NH2OH, we want to calculate percentage of nitrogen, percentage of hydrogen and percentage of oxygen. See here, percentage of nitrogen. What is the nitrogen's atomic weight? Is 14 into how many nitrogen atoms are there in the given molecule? Only one nitrogen atom. By what is the molecular weight of NH2OH? See here, for nitrogen is 14 plus 2 hydrogens plus 1 hydrogen. Total we have 3 hydrogens. So 3 into 1 is 3 plus 1 oxygen is 16. So 16 plus 3 19. 19 and 14. 43. Right? So by 43. Like that only they take percentage of hydrogen. What is the atomic weight of hydrogen? Is 1 into how many hydrogen atoms are there in the given molecule? 2 hydrogens here and here 1 hydrogen. Total we have a 3 hydrogens. So 1 into 3 by molecular weight of NH2OH is 43. If you want to calculate for percentage of oxygen, you have to take data for the oxygen. How many oxygen atoms are there in NH2OH? Only 1 oxygen atom. So 1 into atomic weight of oxygen is 16 by total is 43. If you calculate this 14 by 43, 3 by 43 and 16 by 43. If you calculate this, you will get the respective percentages of nitrogen and hydrogen and oxygen in NH2OH, right? So this is the calculation how to calculate the mass percentage and percentage mass for the given molecule, right? So let us come to the next one. This is empirical formula and molecular formula, and very important also. What is meant by empirical formula? What is meant by molecular formula? First of all, we should know what are its definitions. See, molecular formula, we know molecular formula. Empirical formula keep aside. First should take the molecular formula. What is the molecular formula? Molecular formula means suppose CH4 is there. What is the methane is there? What is the molecular formula for methane? CH3. Ammonia. What is the molecular formula for ammonia? NH3, like we are telling, right? So molecular formula is nothing but number of atoms present. Number of atoms are combining, different types of atoms are combining, and how many are present, that gives its molecular formula. Ammonia, whenever, wherever you go at any conditions, that NH3 we represent as the ammonia molecule, means 1 nitrogen and 3 hydrogens gives you ammonia molecule. That is its molecular formula, that is fixed. Whenever you see water, water is H2O, that 2:1, 2 moles of hydrogen and 1 mole of oxygen gives you H2O. That H2O is fixed, that is called its molecular formula. Means how actual number of atoms present in the given compound gives its molecular formula. Hydrogen chloride, 1 hydrogen and 1 chlorine, HCl. That particular ratio, 1:1 ratio, how we are taking, that gives you the exact molecular formula. Now come to the empirical formula, right? Empirical formula is nothing but the simplest ratio of the actual number of atoms present in the molecular formula gives you the empirical formula. Don't confuse here, just see here. What is the molecular formula for benzene? C6H6. What is the molecular formula for hydrogen peroxide? H2O2. See, this C6H6 is nothing but that 6 carbons and 6 hydrogens is its actual number of atoms present in the molecular formula. We have to simplify this. Carbons are 6, hydrogens are 6. So I can write 6, then it will be CH. The simplest formula is there, that is called empirical formula. H2O2. Actual number of atoms present in a molecule gives you the molecular formula. Always hydrogen peroxide means you have to take H2O2 only, 2 hydrogens and 2 oxygens should present in that. Then only we consider that as a hydrogen peroxide. At any conditions, wherever you take out of the universe, anywhere you take, that hydrogen peroxide will be H2O2 only. So that H2O2, the simplest number you have to take. Here 2 hydrogens are there, 2 oxygens are there, 2 if you get, then it will be the simplest formula will be HO. Then that is called its empirical formula. So what is a molecular formula, what is empirical formula? A formula is symbolic representation of one molecule of the substance which tells the number and kinds of atoms of various elements. Simply the definition is actual number of, the simplest number of atoms present in the molecular formula gives you the empirical formula. You can consider like that. Molecular formula means actual number of atoms present. See here, in the molecule of benzene contains 6 atoms of carbon and 6 atoms of hydrogen, that is its molecular formula. Take the simplest number from that molecular formula, it gives you the empirical formula. Here very important one is calculations of empirical formula and molecular formula. How to calculate this empirical formula and molecular formula is very important, right? See, one factor, see here, CH is the empirical formula. If you multiply this CH with 6, that gives you C6 and H6, that is its molecular formula. So one factor is differentiating empirical formula unit and molecular formula unit, that is called N factor. If you find that N factor, you can write the empirical formula and molecular formula, right? So generally what is the relation between that empirical formula and molecular formula is nothing but molecular formula is equals to N into empirical formula. This empirical formula into N gives you the molecular formula of the compound. Suppose see here, C6H6 benzene, if you take, empirical formula of benzene is CH. But if you multiply that, N factor is 6, will gives you the C6H6, that 6 is called N factor. How to calculate that 6? N equal to empirical formula weight, molecular formula weight by empirical formula weight gives you that N factor. If you take example 1 application, then you will understand how to calculate the empirical formula and molecular formula. Let us see one problem here. So here they given the same, the molecular formula of the compound, molecular formula equal to N into empirical formula. This N can be 1, 2, 3, that depends, right? So now come to the calculations of empirical formula and molecular formula. Here they have given one problem. Let us see. In this problem they have given some percentages. See, in the most common form of nylon is nylon 6, right? That nylon 6 contains 63.68% of carbon. Means first of all read the problem clearly. 63.68% carbon, 9.80% of hydrogen, 12.38% of nitrogen and 14.14% of oxygen. Means in this compound 4 elements are present. What is that? Carbon is present, hydrogen is present, nitrogen is present, oxygen is present. That is what we written in this tabular form. It makes simple. How to do the problem makes simple if you take the tabular form. Carbon, hydrogen, nitrogen, oxygen. What are the elements they have given? We listed out, and the symbol for that carbon C, hydrogen H, like that. And the given compositions are 63.68% for carbon, hydrogen is 9.80%, nitrogen is 12.38% and oxygen is 14.14% they have given, right? So first of all, what is the first step to calculate the empirical formula for the given percentages, right? So first step is percentage by its atomic mass. Suppose carbon is there, 63.68 is the percentage given in the problem by atomic mass of carbon, means 63.68 by 12 is the atomic ratio. Like that you have to do for all the elements. Hydrogen 9.80% he said, but its atomic mass is 9.80 by 1. Nitrogen's atomic mass is 14, 12.38 by 14. Oxygen's atomic mass is 14.14 is given, its atomic mass is 16. So 14.14 by 16. Just you calculate this, you will get some numbers, right? What is the second step? So the first step to calculate the empirical formula is the given percentage by its atomic mass. Then you will get some number like this here, 5.30, 9.80, 0.88, 0.88 like. The second step to calculate empirical formula, out of these atomic ratios, which is the smallest one? It is 5.30, 9.80, 0.88, 0.88. 0.88 is the smallest number. So you have to divide with the 0.88 all the atomic ratios. See, 5.30 by 0.88, 9.80 by 0.88, 0.88 by 0.88, 0.88 by. Now you calculate. 5.30 by 0.88 gives you 6 and this one gives 11, it is 1 and 1. So what we understand, carbon simplest atomic ratio is 6, C6. Hydrogens are how many times? 11, C6H11. Nitrogen is 1, so N1. Oxygen is also, you got here the number is 1, you got the number here is 1, so O1 means C6H11NO. This is the empirical formula for nylon 6. He has to calculate the empirical formula only. So what is the empirical formula for nylon 6 is C6H11ON. So to calculate empirical formula, 3 steps. First, the given percentages by its atomic masses. Second one, calculate the atomic ratio and choose the smallest number in that atomic ratio. Third step is divide with the smallest number all the atomic ratios. Then you will get some numbers that will be represents its empirical formula. Right? Now, after knowing the empirical formula, this is C6H11NO, this is called empirical formula, right? So, empirical formula mass is nothing but 1 carbon is 12 into 6, 11 into 1, nitrogen 1 into 14, oxygens also 1 are there, 1 into 16, total you are getting 113U, that small u represents atomic mass units. So, total 113. So, as previous we have discussed, N equal to, N factor equal to molecular mass by empirical formula mass. Molecular mass is 226, that will be given in the problem. Sometimes they will give vapor density like also. If you know vapor density, you will know the molecular mass, because the relation between molecular mass and vapor density is molecular mass equal to 2 into vapor density. Right? So, 226 by 113 gives you 2. So, N factor is 2. If you multiply this whole empirical formula with 2, you will get C12, H22, N2 and O2. This will be the molecular formula for nylon 6. Empirical formula is C6H11NO and molecular formula is C12H22, N2 and O2. Right? So, that is what they given, C12H22, N2, O2, that is the molecular formula. So, like this stepwise we will calculate the empirical formula and molecular formula calculations, right. So, we have to remember basically 3 steps. First, the given percentages, next with atomic masses, divide those, you will get atomic ratio, which is the smallest atomic ratio, divide with that the remaining atomic ratios, you will get some number that gives you empirical formula. Once you know the empirical formula weight, you can calculate the N factor, then you can find the molecular formula weight. Remember, in the formula they will give molecular formula weight, or else they will give vapor density. If they give vapor density, you have to calculate 2 into vapor density will gives you the molecular formula weight. This is about the calculations of empirical formula and molecular formula, right. So, now this is about the mole concept. Now we are officially entering into the stoichiometry. What is meant by stoichiometry? Here till now we have studied about the 1 mole of substance, how many number of atoms, how many number of molecules, all these we have studied. But in the stoichiometry, we are going to do the stoichiometric calculations. What is meant by this stoichiometry? What we are going to learn in this stoichiometry? See here. Stoichiometry is a branch of chemistry dealing with the relationship between the combined and elements or compounds in a chemical reactions. So here now we are talking about the chemical reaction. Suppose A plus B gives you C plus D. This is one of the chemical equation. Either this chemical equation is a stoichiometric equation or not. What is meant by stoichiometric equation? This stoichiometric equation is also called as balanced chemical equation. What is balanced chemical equation? Number of atoms present in the reactant side is equal to number of atoms present in the product side is called its stoichiometric equation. Whenever you are doing the stoichiometric calculations, compulsory you should take a balanced equation. If you calculate for unbalanced equation, that is not the correct stoichiometry for the equation, right? So measurements, the qualitative and the quantitative measurements is nothing but called stoichiometry. Suppose see N2 plus 3H2 gives rise to NH3, means otherwise hydrogen reacts with oxygen gives water. How much amount of hydrogen reacts with how much amount of oxygen gives you how much amount of H2O. Calculating that amounts in presence of weight, in terms of volume, anything, that calculation is nothing but called stoichiometry. While doing these calculations, we should take the balanced chemical equation only. What is balanced? Number of atoms present in the reactant side. Always see, this is the arrow. For this arrow, right side, left side one A plus B will be the reactants, and this is called the products. Reactants or products. Reactant side, how many number of atoms are there? Product side, how many number of atoms are there? Both should be equal. I will take one example. Suppose see here, they have given one example. 2CO plus O2 gives rise to 2CO2. 2CO plus O2 is the reactant. 2CO2 is the product, right? See how many number of carbon atoms are there? Reactants side 2 carbons. Products side also 2 carbons. Come to the oxygens. These two comes to a carbon, comes to oxygen, but these two comes to oxygen only. These two represents the number of molecules. These two represents the number of atoms. That small variation is very important. So 2 oxygens in CO and O2 means 2 oxygens in O2 molecule. Total we have a 4 oxygens. So here 2 carbons, 2 2s are 4 oxygens. Reactant side 2 carbons, so products side 2 carbons. Reactants side 4 oxygens, so products side 4 oxygens. So number of atoms are equal in both reactants and product side. So we can say this reaction is a chemically balanced equation or a stoichiometric equation. If these are not equal, then that reaction is said to be skeletal equation or unbalanced equation, right? So calculation, see how to calculate these calculations based on chemical equations. See, here in this we are going to calculate molecular relation between the reactants and products. In this, the reactions between the reactants and products and the molar relation between the reactants and products, weight relation and volume relation. All these we are going to calculate, weight relationship. So here generally the types of stoichiometric calculations are 3 types. Weight relation, weight volume relation and volume relations also we have, right? So how to represent these molecular relations between the reactants and products and how to read one reaction. Suppose see 2CO plus O2 gives rise to 2CO2. How to represent this reaction? See, I will write here the reaction 2CO plus O2 gives rise to 2CO2. This is our reaction. How to read that reaction? See, these many types we have. In terms of molecules we can read 2 molecules of carbon monoxide reacting with 1 molecule of oxygen gives you 2 molecules of carbon dioxide. That is in terms of molecules. Here he given na molecular relation, molar relation, weight relation, volume relation. The first type with molecular, 2 molecules of carbon monoxide reacts with 1 molecule of oxygen, gives you 2 molecules of carbon dioxide. Next, in terms of molar, means we have to take moles. This number represents the number of moles. 2 moles of carbon monoxide reacts with 1 mole of oxygen, gives you 2 moles of carbon dioxide. This is the representation with molar. This number 2 moles of carbon monoxide represents with 1 mole of oxygen, gives you 2 moles of carbon dioxide. That is the molar representation. Now weight representation. How to represent with weight? Generally, weight of carbon monoxide is 28 grams. Weight of oxygen is 1 oxygen 16, so 32 grams. Carbon dioxide is 44 grams. See, 2 into 28 grams of carbon monoxide means 2 into 28 grams of carbon monoxide reacts with 32 grams of oxygen, gives 2 into 44 grams of carbon dioxide. 2 into 44 grams of carbon dioxide. Weight representation. Molecular representation, molar representation, weight representation. Now volume also we have. Generally I said gram molar volume means what is that? 22.4 liters. In some books there is 22.7 liters. Nowadays they are following. But from the long back we are following 22.4 liters. So you can take even 22.7 liters also. Here 2 into 22.4 liters of carbon monoxide reacting with 1 into 22.4 moles of oxygen gives you 2 into 22.4 moles of carbon dioxide. Volume representation. So one chemical equation we can represent in 4 types: molecular representation, molar representation, weight representation of reactants and products, and volume representation of the weights and reactants and products, right? So thank you. This is about the stoichiometry. The only part we left in stoichiometry, types of stoichiometric calculations, means weight relation, weight volume relation, and volume relation. In next video we can learn how to calculate these relationships in the stoichiometry by using the given stoichiometric reactions. Okay, thank you so much.